Whenever people look at the night sky, they say, there are billions of stars, so aliens must be visiting us. That sounds reasonable, until you notice something. Suppose you park your car in a parking lot with 10,000 spaces. You leave for 1 minute. When you come back, your car is still there. Now someone says, impossible! With so many drivers, someone must have taken it. See the mistake? Large numbers don't guarantee events, they only allow them. The misconception is that big universe must result in inevitable encounters. But probability isn't destiny. Imagine rolling 1 trillion dice once. You expect some sixes, but not in any particular seat in your classroom. Earth is a very particular seat. Science says the universe allows life widely, but says nothing about traffic toward your address. Now let's talk about the rule everyone tries to escape. The cosmic speed limit. You know how cities have speed limits? You can build a better car, smoother engine, stronger tires, but the road still curves, traffic still exists, and eventually going faster just stops working. The universe has one of those limits. Light, the thing that turns night into day, moves at the maximum speed anything can move. Not just fast, final. People often say, sure, that's our physics. Aliens will invent something better. But physics isn't like technology upgrades. You can improve a bicycle into a motorcycle, but you cannot invent a way to fall upward. Let's make it relatable. When you video call someone across the world, there's a tiny delay, a fraction of a second. You barely notice it. Now imagine the other person is on Mars. The delay becomes minutes. On the nearest star, 4 years. You say hello, and wait 4 years to hear hello back. Conversation stops being conversation. It becomes archaeology. Imagine you decide to drive to a friend's house, but every meter you travel makes time outside pass faster. By the time you arrive, centuries have passed. That's actually what near-light travel does. So even if aliens could travel extremely fast, they wouldn't arrive in our time. They'd arrive in a different era of Earth, maybe dinosaurs, maybe ice age, maybe empty oceans. The misconception is that advanced technology removes limits. No, it approaches limits. You can get closer and closer to the speed of light. But the closer you get, the more energy the universe demands, absurdly more, like trying to push a mountain to go 1 extra inch faster. So the universe isn't stopping aliens with danger, it's stopping them with bookkeeping. And physics keeps perfect accounts. Now, people often imagine alien civilizations the way we imagine ourselves during the age of exploration, ships sailing across oceans just to see what's over the horizon. But history hides an important detail. Humans didn't cross oceans purely out of curiosity. They crossed because they expected something valuable on the other side. Land, spices, trade routes, resources, survival. Exploration had a payoff. Without payoff, nobody funds the voyage. Let's use a simple everyday example. Suppose someone offers you a free ticket, but it's a bus ride that lasts your entire lifetime. No stopping, no turning back. When you finally arrive, you get to see a parking lot identical to the one near your house. Would you go? Probably not. Not because you lack curiosity, but because curiosity competes with practicality. That's interstellar travel. Here's the common misconception. Intelligent life automatically wants to expand everywhere. But intelligence often learns efficiency. We invented high-resolution cameras and stopped printing thousands of photographs. We built satellites and stopped sending ships to map coastlines manually. Knowledge travels easier than bodies. Stars across the galaxy contain the same elements: hydrogen, oxygen, carbon. Physics behaves the same everywhere. Chemistry repeats itself, so the expected discovery from visiting another star is not magical cities. It's probably microbes, rocks, or empty planets. The reward becomes small compared to the cost. So the real barrier isn't bravery or intelligence. It's economics, cosmic economics. Civilizations, like people, rarely take infinite journeys to learn what a telescope can already tell them from home. Now here's a very popular idea. Sure, the distances are big, but a sufficiently advanced civilization will invent unbelievable technology. Yes, but there's a quiet character in physics that doesn't care how clever you are, arithmetic. You can improve tools, but you cannot negotiate with numbers. Here's the misconception. Advanced means unlimited. No, advanced means optimized under limits. Even the most futuristic spaceship must obey energy bookkeeping. Let's do a thought experiment. Shrink the entire history of Earth into a single day. Life begins around 4 a.m. Dinosaurs appear near 10:30 p.m. Humans show up at 11:58 p.m. Radio communication, less than the last second before midnight. So if another civilization existed even a few minutes earlier or later in this cosmic clock, we would completely miss each other. Even if aliens detected Earth a million years ago and started traveling, they wouldn't find cities. If they leave today, they might arrive after humanity is gone. So the problem isn't that civilizations don't exist. Synchronization, space separates us by distance. Time separates us by existence itself. And time, unlike distance, cannot be crossed, only endured. Now, a very popular belief is a quieter one. Aliens are already here, just observing us, not invading, not landing, just watching, like scientists studying wildlife. It sounds polite, almost flattering. But let's think about what observing really means. Imagine you're standing on a hill overlooking a massive forest stretching to the horizon. Somewhere inside it, a single ant is walking along a leaf. Could you watch that specific ant continuously? Of course not. Not because you lack curiosity, but because attention requires resolution. You look where something noticeable happens. Here's the misconception. We assume Earth is interesting at a cosmic scale. But interesting compared to what? In the universe, there are exploding stars, black holes tearing space, planets larger than our sun's storms, entire galaxies colliding. Against that background, Earth's radio chatter is whispering. So aliens might exist even nearby and still not know we're here. Not because they're hiding. Because in a vast universe, noticing something small is harder than imagining it. Now stretch that to thousands or hundreds of thousands of years. A spaceship doesn't just travel through distance, it travels through generations. The original travelers would never see the destination. Their children wouldn't either. Entire civilizations would live and die inside a vehicle whose purpose belongs to distant ancestors. Here's the common misconception. A sufficiently advanced species adapts to anything. Actually, evolution specializes. Fish adapt to water, birds to air, trees to soil. Life stabilizes around environments. It doesn't prefer permanent migration. Intelligence doesn't erase biology. A civilization capable of surviving millions of years probably learned stability, building habitats, controlled worlds, or digital environments, instead of sending fragile organisms across lethal voids. Space travel isn't just a physics problem, it's a life problem. And life, by its nature, prefers routes over endless roads. Now here's where conversations about aliens often quietly slip. Someone says interstellar travel is possible according to physics. And that's true. But we immediately, almost automatically, replace possible with likely. Those are not the same word. It is physically possible for you to walk from Karachi to Paris. Nothing in physics stops you. Gravity works, oxygen exists, roads connect continents. But you don't do it. Why? Because practicality matters more than possibility. You choose planes, screens, photos, maps, information instead of presence. Here's the misconception. If a civilization can do something, eventually it will. Nature shows the opposite. Most possible things never happen because they are inefficient. Thought experiment. Imagine you want to read every book ever written. You could travel to every library on Earth one by one, or download digital copies in seconds. An intelligent species trends toward efficiency, not heroics. So when technology improves, travel often decreases. We didn't send people to every mountain to measure height. We launched satellites. We didn't visit every city during meetings, we invented video calls. Progress reduces journeys. Now apply that to aliens. A civilization capable of crossing stars would also be capable of building extremely powerful telescopes, probes, or simulations far cheaper than sending fragile beings across centuries. Why ship a person when you can ship information? Why ship information when you can infer laws of nature remotely? So yes, star travel might be achievable, but practicality asks, would it be used frequently, randomly, toward unknown targets, for curiosity alone? The universe rewards efficiency, and efficiency rarely sends travelers across darkness just to knock on doors. Capability opens the door. Practicality decides whether anyone walks through it. So here we are, at the final idea, silence. Many people find it mysterious, even unsettling, that we haven't been visited by aliens. But let's step back and think like scientists, not storytellers. Imagine walking along a vast beach at low tide. Each grain of sand is a potential home for someone, perhaps a tiny crab, a shell, or nothing at all. You might spend your entire life walking and never step on the same grain twice, never meet another creature, never even notice most of the beach. Now replace the beach with the galaxy. Each grain is a star, each crab is a civilization. Vast numbers exist, perhaps countless life forms, yet the odds that anyone finds you are vanishingly small. Here's the misconception. If life is common, contact is inevitable. But science isn't about inevitability. Science is about probability, limits, and practical outcomes. Imagine the universe as a gigantic auditorium. Trillions of people are whispering at their own microphones. Each voice can only reach a few seats around them. You might strain to hear someone across the room, but the crowd is enormous. Just because voices exist doesn't mean anyone hears your whisper. Silence isn't absence, it's scale. We also forget that the universe isn't built around our expectations. Stars aren't waiting in formation, planets aren't set up for a meeting, and civilizations don't synchronize like watches. Space is not a neighborhood. It's a vast, probabilistic landscape. Stand in a field and shout. Did anyone respond? Probably not. Not because nobody exists, but because the scale is too large, the timing wrong, and the medium inadequate. That's the universe in a nutshell. Aliens may well exist. Many, perhaps most, of the habitable planets may harbor life. But expecting them to arrive on Earth misunderstands the vastness, the limits of physics, the span of time, and the logic of probability. Arrival itself is a human idea, an assumption that the universe works like a neighborhood rather than an auditorium or a beach. The night sky isn't empty. It's quietly, perfectly, overwhelmingly vast. And the silence? That is not mystery. That is mathematics, physics, and biology all working together. And when we accept that, we see the universe not as lonely, but as a place so logically immense that our expectations of meetings, visits, or encounters seem almost laughably human. The universe is vast, life is possible, but arrival is improbable. And in that improbability, there is a strange, beautiful order.